For this skill, we were given an example graph shown here and asked to label the different transformations that have been performed on it and to assign a parent function to it that had been transformed. So for my parent function, I said that this was originally a sine graph and that the new function that resulted from it would be 2 sine parenthesis 3x minus pi over 2 plus 4. So where each of those transformations comes from is right here for the a value, the amplitude. I said it was 2 because this height right here doesn't look like just 1, which is in a regular sine graph. So I said it was just probably double that height. So it goes up 2 and then comes down 2. For the b value, which I said was 3, that's a horizontal compression of a factor by 1/3. So, and it reduces the period of the function to just 2 pi over 3 in this case, because the period for a sine graph equals 2 pi over b. And if b equals 1, it'd obviously just be 2 pi, which is just a regular sine graph. But for this in particular, since b was 3, it's 2 pi over 3. And that works in with the c value, the horizontal shift to the right by pi over 6. I did this because it didn't look like a large distance that had been transformed, but only just a small distance. And pi over 6 seemed like a reasonable way to write that. For here, you'll see it's written as 3x minus pi over 2. That's because the b value actually lies outside of this parenthesis and is distributed inside. So it'd originally read 2 sine 3 parenthesis x minus pi over 6, but since the 3 is distributed in, you are left with 3x minus pi over 2. And then the plus 4 I just did because it didn't look like it was on just the regular x-axis at 0. So I wanted to lift it up a little bit. And so I just assigned the number 4. And that's where that comes from. For the next part of the problem, we had to take a function. So I chose secant that had the same transformations as the previous graph. So all these transformations listed right here. And it had to have its asymptotes going through the extrema, so the maximums and the minimums of this graph. And they had to be going through there. And then we were asked to analyze that function. So my function was 2 secant parenthesis 3x minus 2, which is the same as in the last problem, plus 4. So the asymptotes I said were at x equals negative pi over 3, which would be right here, would be the soonest one, plus or minus k, meaning any integer, pi over 3. So where any integer times pi over 3 plus or minus negative pi over 3 will be where these asymptotes lie. For the domain, I said it was all real numbers except where x equals negative pi over 9 plus k times pi over 3. And I said this because that's where the graph just doesn't exist, and it also happens to be where sine equals 1. As written here. For the range is pretty easy. You just know that from negative infinity and then to right here, it causes a jump. So it's negative infinity to 2, and then it jumps to 6. So it'd be 6 to just positive infinity. For the maximum of just one period, so from 0 to 2 pi over 3, so these two, I had to find the max. So you just take this one because this one's local extrema is just a minimum, but this one has a maximum. So you would focus on this. So for just one period, I said that the maximum was pi over 2, which is right here. That's the x value, and then 2. So that's the maximum of this parabola-looking part of the graph. For the minimum, I focused on this curve right here, because it's the only curve in this part of the graph in this one period that has a minimum for its local extrema. And so I said that it was at pi over 6 because that's which also happens to be the horizontal shift, and at 6, which is listed also here in the range. As you can see, this is the lowest point of this curve is 6, and it's over by pi over 6. For the increasing area of the graphs, so it would be right here and right here on the graphs, I said it's pi over 6 to pi over 3, and then it's union with pi over 3 to pi over 2 plus 2 pi over 3k, which is just like an infinite number of periods. So for one period, it's just what's listed right here. And these are the x values, not the y values. Just from where... So from pi over 6 to pi over 3, which is right here, that's increasing, and then it jumps to right here. And there's an asymptote right here. For decreasing, it's just the same thing as increasing, but opposite. So it would be right here, this curve, half of the curve, and then right here. So for one period, it would be pi over 2 to 2 pi over 3, union with 2 pi over 3 to 5 pi over 6. And then that's just for one period, so you would add 2 pi over 3k to symbolize every unit. It'd be plus or minus 2 pi over 3k, that's written around, I'm sorry. But to symbolize every period on the graph. For the y-intercept and x-intercept, it's actually pretty easy to find. For the y-intercept, you just set the x in the problem to 0. So that would give you just 0 minus pi over 2, which is just negative pi over 2. But because secant cannot exist here, it's undefined. It doesn't matter what like these transformation values out here are. That's where asymptotes lie. So it will always be just undefined. It cannot exist there. For x-intercepts, also for the y-intercept, it will never, the line x equals 0 is an asymptote, so that's why it can never have an x-intercept. For y-intercept. For x-intercepts, it's at 7 pi over 18 and 0, and then 11 pi over 18 and 0. And that's just for one period. That can be found by inserting 0 for the y value on this half of the equation, and then solving for x. So it's actually, and then transferring that into just radians, so it would be on this graph, and it's not too hard.